In this section, or in this video, we are going to now take a look at some other types of linear equations. So in the previous video, we went over positive and negative linear equations. In this video, we're going to take a look at linear equations that have a slope of 0, or what is known as an undefined slope. And with these types of equations or graphs, we will only see one variable. So you can either see, this should be equation, you will either see an equation that looks like y equals some value or x equals some value. So with that being said, let's just dive right into some examples. So in the following examples, let's graph equations that have a number set equal to x. So all these following examples will have equations that set equal to x and some value. So once we graph these equations, then we're going to determine the x-intercept, y-intercept if there is one, and the slope. So looking at example number 1, we're given graph x equals 1. Well, how are we going to graph this equation if we've never seen what this equation looks like graphed before? Just x equals some value. Well, whenever you run into this scenario where you're asked to graph something and you don't know exactly what it looks like or how to go about it, this can be your safe method, your go-to method. You create an XY chart. So what this means is that you plug in values of x, and then you see what you get out for your y value, or what you get out. So in this case, I'm going to plug in, let's say I'm going to plug in the value 0 for x. Let's see what happens. Well, if I plug in 0 for x, we get 0 equals 1. But 0 isn't equal to 1, right? So what happens now? What does y equal? Well, recall in Unit 2, the previous unit, when we were learning how to solve linear equations, this is why solving linear equations is important, because it's used all the time in algebra. So if you don't understand how to solve linear equations, definitely take a look at Unit 2, because recall, when we get a false statement, for example, 0 equals 1, that means no solutions. So for our y values, graphically, our y values don't exist when x equals 0. So that's what that means. And DNE is just an abbreviation for does not exist. So in this video, I'll be writing DNE, does not exist. So I encourage you to take a note of that. And then what about the x value of 1? Let's see. If I plug in the x value of 1, you'd get 1 equals 1. Well, that is a true statement. So what does that mean? Well, remember in Unit 2, when we were solving linear equations and we got a true statement, for example, 1 equals 1, what did we write as our answer? We wrote our answer as all real solutions. And recall, when we get all real solutions, that means you can plug in any value and you get a true statement. But in this case, we can't plug in any value for x and get a true statement. As we've seen before, if you plugged in 0, we get a false statement. So what does this mean? Well, because we're making an XY chart, this means that when x equals 1, our y values can take on an infinite amount of solutions. Meaning when x equals 1, our y values are infinite. Also, this symbol here, I'll write it up here. I will also be writing the symbol in this section. Here, let me write it a little bit better. It's just like the number 8, but lying down. So, no, looks like this. No, I'm still doing it bad. There you go, that's a little better. So this, if you aren't aware, this symbol means infinity. So when we get all real solutions for our y values, that means that our y values are going to infinity, both positive and negative infinity. So let's see what this looks like graphically. So I'm gonna just graph it here actually. So this is our y-axis, and then we're going to have our x-axis. So as we've seen here, when x equals 1, so I'm just going to draw a dash here, we have infinite y solutions. So the graph x equals 1 looks like this. We have a vertical line that goes straight up and down. And that's the graph x equals 1. So, but now we're not done with the problem. We still have to identify a couple things. So we have to identify the x-intercept, the y-intercept if there is one, and the slope. So let's see. Our x-intercept, well, our x-intercept is the point of the graph that intersects the x-axis, which that's here. So our x-intercept, I'm going to just write INT for intercept abbreviation. Our x-intercept is at the point 1, 0. Now for y-intercept, well, there isn't a single point that this graph will ever cross the y-axis. So this graph doesn't have a y-intercept. So I'm going to write DNE does not exist. And then for our slope, well, our slope, whenever you have a vertical line like this that goes straight up and down, your slope is called undefined. And then sometimes in textbooks and other various places, you can see undefined abbreviated as UND. That's not a V, that's a U, by the way. There you go. That looks a little bit better. UND. A little bit. Okay, so that's our answer. That's what we need. Alrighty, so for example number 2, we have graph x equals -2. So now that we have a general idea of what this graph looked like, I will tell you now that all graphs where you have x equals some number will be vertical lines. All of them will look exactly like this. So they're all going to be vertical lines on the x-axis when you have x equals some number. So looking at example number 2, using that same logic, let's just start right away by drawing out the x and y axis. So we have the x-axis and the y-axis. This one is x equals -2. So that means we're going to go down to -2. And then here is going to be our vertical line at x equals -2. Now let's identify our x-intercept, y-intercept, and our slope. So I encourage you to actually pause the video and try to identify the x, the y-intercept if there is one, and the slope. And assuming you have worked through those on your own, let's go through it. So the x, we have an x-intercept here at -2, 0. Or at the point -2, 0. And we don't have a y-intercept, so I'm going to write DNE, does not exist. And our slope, well, our slope is also undefined. I'm just going to write UND for undefined. And then for example number 3, I encourage you to pause the video and try this on your own. Graph x equals 0, and then identify the x-intercept, the y-intercept, and the slope. And assuming you've worked through it, let's go through this. Because this example specifically is a little bit different, or can be kind of confusing. So let's go through it. So we have our y-axis here. Then we're going to have our x-axis here. So recall, whenever we have a number set equal to x, we have a vertical line. But this is specifically when x is 0. So on this x-axis, x is 0 right here at the origin. So what that means is the line x equals 0 is a vertical line right on top of the y-axis, like this. So this is the equation x equals 0. So for our x-intercept, well, our x-intercept is right here. This line crosses through the x-axis at the origin, which is the point 0, 0. And then our y-intercept, well, I mean, this line is on the y-axis, right? So we can just say that for our y-intercept, well, we have infinitely many y-intercepts. Because the line, this equation, is directly on top of the y-axis. So the y-intercepts are infinite. And then for our slope, well, our slope is still undefined here because we have a vertical line and there is no clear rise or run that's going on here. All right, so now let's go the other way. So we're going to do the same thing now, except for we're going to have an equation, and we're going to have some value set equal to y now. So as I did for our first example, when we were looking at x equals some value, let's do this. But in this case, because it's set equal to y, I'm actually going to end up doing yx. So I'm going to plug in a value for y and see what our solution would be for our x values. So looking here, I'm going to plug in the value of 2. Well, when I plug in the value of 2, we get 2 equals 3. Not a true statement, right? So our x values does not exist, or they do not exist, DNE. Now let's try when our y values are equal to 3. Bringing that in, we get 3 equals 3. That's a true statement. So that means for all of our x values, when y is 3, we get all real solutions. Or what this means in terms of our x values is that we have infinite x values. Recall this sign means infinity. So when y is 3, we have infinite x values. So let's sketch this out visually, see what this looks like. So this is our y-axis, this is our x-axis, and we have to get to the dash y equals 3. So I'm going to go up 3. 1, 2, 3. Now, at y equals 3, which is right here, we have infinite x values. So that means we're going to go infinitely into the negative direction of our x values and infinitely to the right in our positive direction for x values. So here's what this will look like. It'll just be a horizontal line like so at y equals 3. And that's your graph. Now, let's identify x-intercepts, any x-intercepts, any y-intercepts, and our slope. Well, we don't have any x-intercepts. We do have a y-intercept at the point 0, 3. And then our slope, so whenever we have a horizontal line, your slope is 0. And there you are. Now using the same logic, let's graph y equals -2. I'm going to bring the x-axis up here a little bit because now y equals 2, so we're going to be in the negative y-axis. So I'm going to go down by 2, -1, -2. And we have infinite x values when y equals 2. So our graph will look like this, a horizontal line at y equals 2. Or -2, my apologies. So, x-intercepts, we have none. Y-intercepts, well, we have one y-intercept at the point 0, -2. And then our slope, well, because this is a horizontal line, our slope is 0. Now, taking a look at example 3, pause the video and try this one on your own. Graph the equation and then state if you have any x-intercepts, y-intercepts, and what your slope is. And assuming you fully work through the problem on your own, let's go through it. So we're going to have the y-axis. Actually, I don't know why I'm making this so big. I don't need to. I'm going to click here. So we're going to have our y-axis, and then we're going to have our x-axis. So let's see. So we know when y equals 0, that's going to be at this point in the graph. And as we've seen in the other two examples, wherever the point is that y is set equal to, we have infinite x values. So when y is equal to 0, which is here, we're going to have infinite x values. So that means that y equals 0 is a graph that just lays directly on top of the x-axis. So for our x-intercept, well, as we've seen when we found what y equals 0 is, we have infinite x-intercepts. And that's because this line is just directly on top of the x-axis. Now for y-intercepts, well, this graph crosses through the x-axis, or the y-axis, my apologies. This graph crosses through the y-axis at the origin, which recall the origin of the xy plane is the point 0, 0. And then for our slope, well, because this is a horizontal line, our slope is 0. Now, taking a look at example 3, we're going to now be given the slope. We're going to now be given the slope and an intercept of the graph. And we're going to have to, using that information, we're going to have to write the equation of the line. So let's do so. Actually, I encourage you to pause the video and try both number 1 and number 2 on your own using the information we've done above. And assuming you tried both these examples, let's go through this together. So, for example, number 1, we have a slope of 0 and a y-intercept of -2. This is wrong. This should be 0, -2. So, for example, number 1, we have the slope of 0 and the y-intercept 0, -2. So using that information, well, we know that when the slope is equal to 0, we have a horizontal line, like so. And when we have a horizontal line, I also made a mistake there. This should be y equals 0. When we have a horizontal line, we know that means that we have y equals some number. And because this line is crossing through the y-axis, because we have a y-intercept, that means that we're crossing through the y-axis specifically at -2. So this equation is going to be y equals -2. Looking at example number 2, we have a slope that's undefined and an x-intercept of -2, 0. So recall, when we have an undefined slope, that means that our line is going to be vertical, like so. So when we have vertical lines, that means we have infinite y values, because we're going up and down forever, but that means we're going to cross through the x-axis once. So that means we're going to have x equals some number, and because our x-intercept is specifically at the point -2, 0, that's telling us that our equation is x equals -2.